Hello, and I am glad to be with you again as you get more improvement of knowledge at the network. We know the basic component of a simple network, and after we connect those components, how can we make sure that they will work together? And in this case, protocols and models play a main role, where protocols are sets of agreed upon rules that have been created by standard organizations, and models give us a way to visualize the rules and their place in our network. And in this module that we will discuss together, we will have an overview of network protocols and models, and we will have a much deeper understanding of how networks actually work. And at this module, we will explain how network protocols enable devices to access local and remote network resources. And the top topics that we will discuss, there will be rules, where we will describe the types of rules that are necessary to successfully communication, protocols, where we will explain how protocols are necessary in network communication, protocol suites, where we will explain the purpose of adding to a protocol suite, and reference models, where we explain how the TCP/IP model and OSI model are used to facilitate the standardization in the communication process. We will also explain about data encapsulation, where we will explain how data encapsulation allows data to be transported across the network, and lastly, data access, where we will explain how local hosts access local resources on a network. And at this video, we will be focused at the first topic, which is rules. Networks vary in size, shape, and function. A network can be as complex as devices connected across the internet, or simple as two devices connected directly with each other with a single cable or anything between. However, even the connection is very simple with a wired or wireless physical connection between two end devices, is not enough for them to enable the communication. If we want that communication to occur between those two devices, they must know how to communicate with each other. For example, people exchange ideas using many different communication methods. However, all communication methods have three elements in common. They have the message source, where the message source are people or electronic devices that need to send a message to other individuals or devices. A message destination is the receiver of the message and how he interprets the message, and the channel consists of the media that provide the pathway over which the message travels from the source to destination. So remember, we have the message source, which is the sender, we have the message destination, which is the receiver, and the channel. Sending a message, whether face-to-face communication or even over a network, is governed by rules called protocols. These protocols are specific to the type of communication method being used. For example, the rules that we communicate over the medium like telephone call are not necessarily the same as the rules for using another medium such as sending a letter. So, as you can see at the slides, there are two types of communication: face-to-face communication and over the network communication. At the face-to-face communication, there are two persons that try to communicate with each other. At the over network, there are two devices, a laptop and a personal computer, that will try to communicate with each other. And as you can see, the way they communicate is kind of the same. In both of them, there is a message that needs to be delivered, is the source of the message, the destination of the message, the signals that will be transmitted, and the channel where the message will be delivered. And at the communication face-to-face, before the communication to occur, the two persons must agree on how to communicate. And if the communication is using voice, they must agree first on the language that they will use. And after that, when they have a message to share, they must be able to format the message in a way that is understandable by both of them. For example, if someone is using language but it has a poor sentence structure, the message can be easily misunderstood. See, first they need to agree on how to communicate. The same happens even at the network when two devices try to communicate. Prior to communicate, the devices, the same, must agree on how to communicate, and then they also format the message in a way that is understandable by both of them. It happens the same on both communication between humans and computers. Before communicating with another, individuals must use established rules or agreements to govern the conversation. Let's consider the message that is in the first section. As you can see, it is very hard to read and understand the message. Why? Because it's not properly formatted for the language and even for the grammar. So if we correct them, if we correct the grammar and we format even the language, as we can see at the second section, we are able to read and understand the message. Protocol must account for the following requirements to successfully deliver a message that is understood by the receiver. And those are to identify sender and receiver, common language and grammar, speed and timing of delivery, and even the confirmation or acknowledgement requirements that the message is delivered and is understood. Same as establishment protocols for communication between humans, the protocols that are used in network communication share many of these fundamental traits. But in addition to identifying the source and the destination, computer and network protocols define the details of how a message is transmitted across a network, and the common computer protocols include the following requirements that we will discuss in other slides: message encoding, message formatting and encapsulation, message size, message timing, and message delivery option. For each of them, we will discuss in the slides that come in next. One of the first steps to sending a message is encoding. Encoding is the process of converting information into another acceptable form for transmission, and decoding receives this process to interpret the information. We will still use the analogy between human communication and computer communication over the network, and as you can see in both of them, that is added an encoder and decoder, where the encode converts into information into another acceptable for further transmitter, and the decoder will get the information from the receiver and will decode this information for the destination. And as an analogy, we will first explain the message encoding between human communication. Just imagine that in this case the girl is calling her friend to discuss the detail of a beautiful sunset. To communicate the message, she converts her thoughts into agreed upon language. She then speaks the word using the sound and inflections of spoken language that convey the message. Her friends listen to the description and decode the sounds to understand the message he received. As you can see, right now she is speaking, and by that the other, which means the destination, understood the message. Same even at the network. Encoding between hosts must be in an appropriate format for the medium. Messages sent across the network are first converted into bits by sending host. Each bit is encoded into a pattern of voltages on copper wires, infrared lights in optical fibers, or microwaves for wireless systems. The destination host receives and decodes the signal, in this case, to interpret the message. As you can see, it's transmitted to the destination. Then we will decode it and we will get the message. When a message is sent from source to destination, it must use a specific format or structure. Message formats depend on the type of message and the channel that is used to deliver the message. We're still going to use the analogy between human communication and network communication. As at the analogy of the human communication, we will explain communication when we send a letter. An envelope has the address of a sender and receiver, each located at the proper place on the envelope. If the destination address and formatting are not correct, the letter will not be delivered. The process of placing one message format, in this case the letter, inside another message format, which means inside the envelope, is called encapsulation. So what did we do? We encapsulate the letter, the message, inside the envelope. Decappsulation occurs when the process is reversed by the recipient and the letter is removed from the envelope. And as you can see, let's open the envelope and let's see what we have here. So by analyzing the information, we will have the destination address, the source address, the sender address, and at the encapsulated letter, we will get the start of a message. We will know to who is the letter, what the letter has inside, and who is sending the letter. At the end, we will have the end of a message. Yeah. The same happens even at the network. Similar to sending a letter, a message that is sent over a computer network follows specific format rules for it to be delivered and processed. These format rules are called Internet protocols. An Internet protocol is a protocol with a similar function to the envelope example. The version field will say if we are using Internet Protocol version 4 or version 6. But in the version 6, packets identify the source of the packets and its destination. IP or Internet Protocol is responsible for sending a message from source to the destination over one or more networks, depending on the destination IP address and the source IP address, but we will discuss for them when we will discuss about IP protocol by itself. Another rule of communication is message sizing. A message sizing means how many messages or how much you need to send to the destination for the destination to be enabled to understand the message that you are trying to send. And we still will use the analogy between human communication and network communication. At human communication, we will use a face-to-face communication, and we will explain the message size in there. So when two people communicate with each other, the messages that they send are usually broken into smaller parts, in this case, into sentences. These sentences are limited in size to what the receiving person can process at one time, as it is shown in the picture. If the girl is trying to explain the sunset to the destination, he cannot understand if she gives him the whole message. But if she tries to use the sentences and short sentences in this case, he is able to understand what is she trying to say. The same happens even at the network. When a long message is sent from one host to another over network, it is necessary to break the message into smaller pieces. The rules that govern the size of the pieces or frames communicated across the network are very strict. They can also be different depending on the channel that is used to deliver the message. Frames that are too long or too short will not be delivered at the destination. The size restrictions on frame require the source host to break a long message into individual pieces that meet both the minimum and the maximum size requirements. The long message will be sent in separate frames, where each frame contains a piece of the original message. Each frame will also have its own addressing information. At the receiving host, the individual pieces of the message are reconstructed into the original message, and as you can see, the source is trying to send the whole message to the destination, is not able to understand because it's a long frame. But when he separates the message into smaller pieces or frames, the destination is able to read the message. Message timing is very important in network communication. Message timing includes the flow control, which is the process of managing the rate of data transmission. Flow control defines how much information can be sent and even the speed at which it can be delivered. For example, if one person speaks too quickly, it may be difficult for the receiver to hear and understand the message. In network communication, there are network protocols used by the source and destination devices to negotiate and manage the flow of information. We have even a response time, If a person asks a question and does not hear a response within an acceptable amount of time, the person assumes that no answer is coming and reacts accordingly. The person may repeat the question or instead may go on with the conversation. Hosts on the network use network protocols that specify how long to wait for responses and what action to take if a response timeout occurs. And at the access method, determine when someone can send a message. And as we can see at the figure, there are two persons that are trying to communicate at the same time. And in this case, a collision of information occurs. And it is necessary for two of them to back off and start again. The same happens even at the devices when to try to transmit on wireless LAN mostly. It is necessary for the wireless LAN network interface card to determine whether the wireless medium is available to send a message or not. So these are the important rules about message timing. We will go further with message delivery options. A message can be delivered in different ways. We're still going to use the analogy between human communication and network communication. Let's go with the human communication. When a person wants to communicate information to a single individual, it is called unicast communication. So one person of the source with one destination. But when the person needs to communicate the information to a group of people, it is called multicast communication. So the source is trying to communicate with multiple people. And if the person, so if the source, is trying to communicate with all people in the same area, it is called broadcast communication. And as you can see, this is unicast when source is trying to communicate with one individual. Multicast when the source is trying to communicate with more than one individual. And the broadcast when it's trying to communicate with all the people that are at the same area. Happen even at the network. Network communication has similar delivery options to communicate. There are three types of communication. It is unicast, information is being transmitted to a single end device. Multicast, where information is being transmitted to one or more than one end devices. And broadcast, where the information is being transmitted to all end devices. As you can see here, so the source is trying to communicate only with one end devices. At the multicast communication, a source is trying to communicate more than one end devices. And at the broadcast, the source is trying to communicate with four of them, with all devices that are connected at the network. Thank you for being with me with the first part of protocols and models at the network. We will meet again at the next Monday with the second part, and please do not forget to subscribe in my YouTube channel AA Networking. Have a good day.